Welcome to this interactive study breakdown on alcohols. Alcohols are a key homologous series in organic chemistry, linking hydrocarbons to more complex molecules like aldehydes, ketones, and carboxylic acids. We'll cover two production methods of ethanol, how to classify alcohols as primary, secondary, or tertiary, their oxidation reactions, and the environmental debate around biofuels. By the end, you'll be ready for any exam question on this topic. Let's map out the key concepts. The hydroxyl group is the functional group. The classification depends on the number of carbons attached to the carbon bearing the OH. This determines oxidation products. Primary can go to aldehydes, then carboxylic acids, secondary to ketones, tertiary are resistant. Also, dehydration produces alkenes, and combustion releases energy. Keep this map in mind for every question. Turning to our core notes on ethanol production. Two main routes: hydration of ethene uses high temperature, high pressure, and a phosphoric acid catalyst, giving pure ethanol continuously but relying on non-renewable crude oil. Fermentation uses yeast under warm anaerobic conditions, producing dilute ethanol, which is renewable. Examiners often ask you to compare these, including atom economy, purity, and environmental impact. Remember, fermentation has lower atom economy because it releases carbon dioxide, but it can be carbon neutral if the biomass is sustainably sourced. Now the process of oxidation. Acidified potassium dichromate is the oxidizing agent. For primary alcohols, if you distill the product, you get the aldehyde; if you reflux, you get the carboxylic acid. Secondary alcohols produce ketones, and tertiary alcohols do not oxidize. The color change from orange to green confirms reaction. This is a classic practical you may be asked to describe. Remember, distillation for aldehyde, reflux for carboxylic acid. Let's work through a 6-mark question comparing ethanol production methods. For full marks you need to state specific conditions. For hydration, 300 degrees Celsius, 60 to 70 atm, HPO. For fermentation, yeast, 30 to 40 degrees Celsius, anaerobic. Then compare atom economy and purity. Hydration gives 100% atom economy, fermentation loses co. Hydration gives pure ethanol, fermentation gives dilute. Finally, evaluate sustainability. Hydration is non-renewable, fermentation is renewable but has drawbacks. A well-balanced conclusion that considers both sides will score top marks. Watch out for common pitfalls. Always include specific conditions. Examiners deduct marks for missing details. When classifying alcohols, count the number of carbons directly attached to the carbon with the hydroxy group. For oxidation, remember the sequence and that tertiary alcohols don't oxidize. Don't forget to mention the orange to green color change as evidence of oxidation. And when evaluating production methods, give balanced arguments, include both advantages and disadvantages before concluding. This will secure those evaluation marks. To wrap up, remember the hydroxyl group defines alcohols. Know the two production methods and their specific conditions. Classify alcohols correctly, count those carbons. Control oxidation with distillation or reflux to get different products. Dehydration gives alkenes. Combustion gives carbon dioxide and water. Finally, be ready to evaluate the sustainability of biofuels, considering both environmental and economic factors. With these concepts nailed, you're ready for any alcohol question. Good luck with your revision.